So I would like to welcome everybody to the second webinar in the series for the Horse Management Seminar. First off, let me introduce myself. I'm Dr. Carrie Williams. I am the Equine Extension Specialist at Rutgers University. And this is going to be my, going into my 20th year at Rutgers, and probably close to that many horse management seminars. Ever since COVID, we started running some virtual horse management seminar webinar series. It always is in February, in place of our live face-to-face seminar that was always the second Sunday of February. It has been so popular, and everybody, it's actually had an international audience that we decided to keep it virtual. So welcome. Thank you again for attending. Like I said, the numbers keep ticking up. We're over 200 attendees, so thank you for being one of them. So along with myself, let me introduce Kyle Hartman. Kyle Hartman's with the Equine Science Center, and he has been pivotal in helping me get this organized, including the registration page and all of the behind-the-scenes details. So if you do have any questions or are having any technical difficulties, please just go ahead and send a chat. And the chat will only go to us as panelists. Not everybody will see it, so you can send it to us, and we'll see the chat, and we can help you out there. As we go through, any questions you have for the speakers, though, will not get asked to the speakers unless you put them in the Q&A box at the bottom. So right next to where you would go to chat, you see Q&A, and I see a couple people have had this happen already. And some people are getting echoes, and I'm sorry about that. I'm not quite sure. Maybe Kyle can help you in the chat figure that one out. But that is where you will be asking questions of the speakers. It's just much easier to monitor questions that come through on the Q&A versus on the chat. So with that being said, I'm going to just share my screen and give a little bit of overview as to what the Equine Science Center is. So give me a few minutes, and we will go there.
Good morning. Welcome to the George H. Cook campus, home of the New Jersey Agricultural Experiment Station, the School of Environmental Biological Sciences, and of course, home to the Rutgers Equine Science Center. The Equine Science Center is a soft-walled center where we bring together the best and the brightest to solve challenges impacting horses, horse well-being, and the horse industry. To provide you more details about the research being conducted at the Equine Science Center, and specifically the Equine Exercise Physiology Lab, I'd like to introduce Dr. Kenneth McKeever.
The lab was founded in 1995, and since then it's been one of the most productive research labs in the country, if not the world. We've conducted studies looking at how to care for the aged horse. That's a horse that's over 20. We've looked at various drugs that affect performance. We've even done studies for the Army looking at food extracts that can reduce inflammation. So the Equine Science Center and the Equine Exercise Physiology Lab are a valuable asset to how we care for horses in the state of New Jersey.
So we've all visited this morning the Equine Exercise Physiology Lab, part of the Equine Science Center at Rutgers. We have another facility where cutting-edge research is being carried out, located on Riders Lane, and it is the site of the first of its kind environmental best management practices demonstration horse farm, located here on the George H. Cook campus. The team of scientists who are helping horse farmers become better environmental stewards and caretakers of the land is a team of multidisciplinary faculty, students, and staff led by Dr. Carrie Williams, Dr. Mike Westendorf, PhD student Jennifer Weinard, and other faculty, students, and staff from different departments here at Rutgers and beyond.
Hello, I'm Dr. Carrie Williams, the Equine Extension Specialist here at Rutgers University and the Associate Director of Extension for the Equine Science Center. We are here at the Environmental Best Management Practice Demonstration Horse Farm. This serves as a wonderful venue for the public, farm owners, other industry professionals to come look and see the 8 various best management practices, educational venues that they can use on their farm or in their areas. It is open to the public. You can come anytime. This venue also serves as a great location for research. My current graduate student, Jennifer Weinart, is looking at both cool season and some novel warm season grasses to see the production as well as the horse's metabolism. Some glucose and insulin responses as well as the microbiome will be looked at over the next 2 years of this project. Thank you for visiting all of us at the Equine Science Center. Our website can be found at esc.rutgers.edu.
So I would like to welcome everyone, and hopefully now you are aware of what the Equine Science Center can do. These webinars are free, and they are free because we have a really nice support from the Equine Science Center. And we really encourage you, if anybody has really valued these webinars, that you might consider donating some money. I'll put the link up at the end as well, where you can go and look for something to donate. And any amount of money would be appreciated, because to do things like this, it does take quite a bit of time. So with that being said, I got one more quick thing to do before I introduce our first speaker, and that is a fun little poll to find out who you all are. So I know I keep talking about who we are, but I love to know my audience. So I'm going to share my screen one more time and ask that everybody goes to a site called Menti, and I'm going to provide in the chat a link for everybody. If you click on that link, or you can just go to menti.com and then use this code that's at the top. It's 73071362. I think the key here is, and I just saw it pop up, don't abbreviate your state. And the reason why I want you to put the whole New Jersey or Pennsylvania or West Virginia is because the more people who make that answer as to where you're located, the bigger the word is going to get. So the more Pennsylvanians that say you're in Pennsylvania, that word is going to get bigger and bigger. And I like to do this, and I see everybody's hopping on really quickly, and that's awesome. Thank you. 94, 95, 98 people. I like to see if we have any international. My goal one of these years is to get all 50 states represented. I think we were really close in the first year. We had quite a few. So I would really appreciate it if you just filled out, tell me what state, or just give me the country if you're out of the US. Where are you listening from? And so far, it makes sense that New Jersey is the biggest and has the most listeners, but Pennsylvania and New York are close behind. North Carolina isn't too far behind as well, and I will tell you, you guys will see in a little bit as to why that is, because one of our speakers is from there. We've got some Canadians, so we had a Canadian speaker last week, so I'm sure many of you know Dr. Pearson from there. We've got, I see in the chat, some in North Carolina as well. So I will wait just a little bit as the words stop changing. It is kind of hard to watch sometimes. Oh, I see Brazil. Welcome, Brazil. Thank you. Saskatchewan, another Canadian. That's awesome. A lot of US, a lot of New Jersey. Oh, I see some UK. Awesome. Welcome. Thank you. And again, it's really hard to see sometimes as they're moving so fast. Nova Scotia. So, and quite a few states represented. So I'm going to let you guys keep filling this out. And again, I'm going to put in the Menti in case you guys are just joining us and you might have missed the link. Let me put it in the chat. Again, you can click on that link and join us. So I'm going to go to the next slide, and this next slide is just going to ask you, what is your primary interaction with horses? So you only get to pick two, because I realize if you're a horse owner, you might also give lessons, or you might also be a veterinarian. So pick your two. If you own horses, pick what else you are, or if you're just a horse enthusiast, pick what else might be your primary interaction with horses. And I see, yes, many of you are 42, 43, many of you are horse owners. A lot of enthusiasts, trainers, barn owners. We kind of have a really equal spread here, and I like that. And if you selected other, do me a favor and in the chat, tell me what other you might be, because I know sometimes we have some therapeutic riding instructors or path instructors, sometimes rehabilitation centers, etc. So I would love to know what other you might be. And I see some come through: path and farrier, nutritional consultant, awesome, veterinary technician, equine dental health, a lot more path, a body worker, sports medicine therapist, a lot of equine mental health specialists. Awesome. So that sounds like a fun profession. So we're getting over 150 logged on to Menti. So that's great. That's more than I think we've ever had answering our Menti. So thank you. Harness racing. Awesome. Welcome. Equine assisted education and therapy, gut health supplement rep. Awesome. So these are really great webinars for you all. All right. Well, that was just something fun that I like to do to see who our audience is. So I'm going to go ahead and stop sharing our screen. And I went through everything except for one small thing before our speakers, and that is to thank our sponsor. I love the support of Triple Crown. They have come to all of my programs, and they have been a really big supporter of a lot of my programs. Because these programs are free, I didn't ask for any sponsors, but Triple Crown Feed offered up some door prizes. So each webinar evening, if you hang out until the very end, at 8:30, we're going to randomly select a participant who is still online. I will go ahead and call your name. You will chime into the chat. Yay, I'm here and I won. And then we're going to go ahead and send your email to Kelly Payne. She is the regional representative for Triple Crown. And she will email your selection of prizes, because they have a lot of prizes, not just those for horse owners, but some for non-horse owners as well. So make sure you hang out until the very end, and we'll go ahead and get you your door prize. All right, so that's enough talking from me. I'm going to do one last thing before I turn it over to my speaker, and that is to introduce and welcome Dr. Shannon Pratt-Phillips. I'm really thrilled to have her here with us today, so thank you very much. Shannon grew up in Toronto, Canada. Her love of horses and science led her to study equine nutrition and exercise physiology, both from her Master of Science from the University of Kentucky and her Doctor of Philosophy from the University of Guelph. Dr. Phillips is currently a professor of equine nutrition at the Department of Animal Science at North Carolina State University. So that's why I'm sure many of you from North Carolina are joining in, and we thank you. She joined the faculty at NCSU in 2006, where she teaches in the field of equine science and nutrition, both via traditional face-to-face classes as well as online. Her field of research focuses on glucose metabolism, insulin resistance, and obesity in horses, as well as nutrient requirements for both equine and canine athletes. She's received numerous accolades for her teaching and research efforts. She is currently the vice president of the Equine Science Society, as well as past president for the American Academy of Veterinary Nutrition. She has written numerous review articles, papers, books, lots of popular press articles. I'm sure many of you might have seen her in a lot of her popular press articles. She lives in Raleigh with her husband, Brian, children, Oliver and Isabella, and several pets. And she is an avid tennis player and competes in the hunter ring with her horse, Moulin Rouge. So, Dr. Pratt-Phillips, with that, please take it away and welcome. Thank you.
Awesome. Thank you so much, everybody, for being here. I'm really excited to be able to share some information with all of you. And a special shout out to all of those Canadians who are out there. It's always good to see some sort of home country folks out there. So today I'm going to talk about some potential issues with horses at pasture. And I want to point out that some of the things that I'm going to introduce this week are actually going to be carried on by Dr. Amy Burke next week. And so I'm just going to give you a little bit of a tease on some things, and then again, she'll be carrying the rest of that out. So first off, we want to remember that pasture is extremely important for our horses. It gives our horses some free exercise. It's probably very good for their mental health, although it's always kind of tough to be able to quantify that. We know that horses that have respiratory issues do much better when they're outside. We know that horses being able to continuously consume feed like pasture is very good for their digestive tract health. But perhaps what's forgotten about is that pasture is an excellent source of nutrition. And in the right circumstances, it can also be a very economical choice for feeding your horses. And so I want to just start off with the economics of pasture. And so this was some work that my colleague at NC State did, Dr. Siciliano, and one of our extension agents. And they were basically estimating the amount of pasture and how much that horses would eat in a particular time if they were turned out for 2 hours or 4 hours or 8 hours or 12 hours. And looking at how much hay could actually be replaced by this. So going from 2-hour turnout to 16-hour turnout. And so you can see that for a 1,300-pound horse, so that's our pretty, decent size, warm blood type of horse, they could be replacing almost 30 pounds of hay. And so if that grazing is going to replace the hay, then it also replaces you as a horse owner and facility owner from having to buy that extra hay. And so when we work that backwards based on the price of hay, it can save anywhere from 50 cents to $3 a day, which equates to $15 to $90 a month. And then you can multiply that out by 12 to see that there's some pretty substantial savings that you can get from good pasture. All right. The other thing that's super important is the nutrition of pasture. And so what I've done here is I have determined the nutritional requirements for a 500-kilogram horse that was in light work. And so maybe not your completely idle pasture pet, but also not your weekend warrior type of horse that's going off to horse shows every weekend, but maybe a horse that might be ridden a couple times a week in light work. And the graph is showing the percentage of the NRC that's met through consuming pasture. And so how I figured this out and how much pasture the horse was actually eating was I was assuming that a horse was actually eating enough pasture to reach those energy requirements. And so that wound up being about 2.2% of that horse's body weight if you take out all the water from the pasture, that's how it worked out to be. And so you can see that digestible energy, of course, is sitting at about 100%, but eating that much pasture for a horse is providing more than 2 times the amount of protein, certainly lots of lysine, calcium, and phosphorus, lots of potassium, magnesium, even some sulfur, iron, manganese, and lots of different minerals that horses are going to need. Of course, as a pasture, it's also going to be rich in vitamin E and beta carotene, and so that's going to be a precursor for vitamin A. Also, if the horses are hanging out in the sunshine, they're also going to be able to synthesize that vitamin D by their skin. I do have a couple arrows that you can see where those nutrients are not being met by pasture. And also some of those other minerals, for example, iron or manganese and selenium in particular, those can be quite varied in the pasture. And so I used the average values from a source called Equine Analytical that does a lot of pasture and hay analyses. And so these were their average values. And so you can see that there would be quite a bit of variation, but certainly there is room so that horses that were living at pasture, they would be able to meet most of their nutrient requirements through pasture alone. But of course, they would always need water. And then they might also be requiring a little bit of salt, that's sodium chloride, and then perhaps some additional minerals as well. But so pasture is really, really great for horses. And of course, in that previous example, I said that the horse was eating enough pasture to meet those energy requirements as that horse needed. But in fact, pasture can be quite high in calories, energy calories. So we use calories, megacalories. That's the proper term for energy. I know a lot of horse owners tend to use sort of oomph or spirit, and they say their horse has too much energy. But from a nutritional standpoint, we like to talk about calories. And so this graph here initially shows the digestible energy requirement. And these are now written in megacalories per kilogram dry matter. So if a horse is going and eating pasture, this is the amount of calories it needs to have per kilogram of dry matter for that horse to be able to meet its requirements. And so you can see we've got different requirements for different types of horses in this case. So our horse at maintenance, maybe our gestating pregnant mare, our mare in lactation, our weanling, maybe our heavier horse, and then perhaps our horse in intense work. And what you can see is that for our horse at maintenance, and probably also our horse that might be at light work, their nutritional requirements for energy are going to be quite a bit lower. This green bar is showing the range where pasture usually sits. So pasture usually has between 2 and 2.4 megacals per kilogram on a dry matter basis. And so that actually provides too many calories for lots of different horses, and in particular, these horses at maintenance, and perhaps even for some of our other types of horses as well. Now, a horse that's lactating or our growing horses or those that are in intense work, they could meet many of their energy requirements, but they probably need some additional sources as well. Now, if we look at protein, here we can see that the hay, the pasture actually tends to provide far more protein than more classes of horses, but there might be some horses, again, that are lactating or that are growing that need slightly higher protein requirements than what pasture can provide. But so ultimately, hopefully this is showing you that pasture can be an excellent source of nutrition, and perhaps for some types of horses, it perhaps can give too many nutrients, and in particular calories. So highlighting that point right there. We also have to know that pasture intake varies widely between horses, and there have been several studies that are summarized here in this graph that have used different methods to try to quantify how much pasture a horse actually eats when they have free access to pasture for 24 hours. And they found, using several of these different methods of analysis, that the ranges are between 1.4 and 3.3 grams of dry matter per kilogram body weight of horse. And so what that means is for a 500 kilogram horse that's idle and not really in any work, their calorie requirements are 16.7 megacalories per day. That pasture intake and how much they can eat based on that range, and then also based on the average energy density of the hay, these horses could be consuming more hay than what's required for a 500 kilogram racehorse. And so very quickly, we can start to see what perhaps some problems are with free choice pasture intake for some of our horses that might have lower requirements, or simply those that like to eat a lot of pasture. And so I kind of like to suggest that pasture intake for some horses is kind of like going to the buffet. There is all you can eat. And sometimes people might eat in moderation when they go to a buffet, but in some cases, we don't. And so uncontrolled pasture intake can result in consuming too many calories, which will result in obesity. Of course, we also know that uncontrolled pasture intake can also lead to laminitis. And of course, laminitis is this devastating condition where the hoof wall and the coffin bone can separate due to this inflammation of these structures between the coffin bone and the hoof wall of the horse, called the laminae. And we can see that normally they are kept in this nice arrangement. I always like to say they're like fingers or Velcro. And when a horse develops laminitis, those laminae become inflamed and they can actually start to break apart and separate. And then this is where we can have the very painful condition where the horse's coffin bone can rotate. And in many cases, it could be so painful that the best course of action is euthanasia. So how does this all come together? And to just show you a little bit more data to show that this is an older study now, but looking at percentage causes, percentage of laminitis cases for perceived cause. So what we think caused it. And you can see that grazing lush pasture is a really high case for these. Also, another bit of information that's kind of interesting is looking at the prevalence of laminitis across months. And so this was over in the UK. But you can see that we saw increased cases of laminitis when we had increased hours of sunshine. And we will talk a little bit about this in a few minutes. So what is the link? There are actually two potential links. One of them is that this excessive pasture intake can result in obesity. And as we all know, obesity is this inflammatory condition. We can see insulin dysregulation, equine metabolic syndrome, and In fact, we also have this condition sort of associated with obesity, equine metabolic syndrome, with a newer phrase called hyperinsulinemia associated laminitis. Also associated with the potential risk of pasture is simply the amount of sugars that are in the pasture itself, because those can result in increased glucose concentrations when the horse eats them, which can then result in increased insulin concentrations, and that can be potentially detrimental to the horses. And also we could have a non-structural carbohydrate overload in the digestive tract. So potentially different mechanism of disrupting the hoof wall. And so we'll talk a little bit more about some of these. And so we'll first off talk about this excessive pasture intake as it relates to obesity. And so when we look at obesity, one of the easiest ways that most horse owners and veterinarians can use to assess obesity is the body condition scoring system. And so this is the scale from 1 to 9, where 1 is considered a horse that is grossly emaciated. Hopefully you never see a horse that's 1. They're probably lying on the ground because they're so thin and they don't have the energetic reserves to even stand up. 9 is a horse that is grossly obese, and hopefully you never see one of those either. 5 is sort of what we consider our happy medium. Anywhere between 4 even to a 6 is probably okay. Once we get above a score of 6, horses are considered overweight. And once they get over a score of 7, then they're considered obese. And obesity is a big problem in our horse industry. We see all kinds of obese horses, as you can see by these three pictures. You might even be looking at this one and thinking, oh, he doesn't look so bad. He just looks a little chunky. Well, chunky is not good. Same with our ponies. We say they look like our little Thelwell ponies and plump and cute. Also very dangerous for those animals. We can also take a look at these horses' necks, because it's been shown that the adipose tissue within the crest of the neck can be more metabolically active and can play a significant role in some metabolic syndromes. And so the Cresty neck score was derived, and this is a 0 to 5 scale, where a score of 0 is where a horse has no crest whatsoever. And then a 4 would be sort of represented by this horse, where it's quite a large mass that appears to be sitting on top of the horse's neck. And then 5 would actually be so big that it is flopped over to one side. Now, we know that obesity is more severe. That adipose tissue doesn't just store calories for later use. It's not just an energy storage. Over the past 20 years, there's been a lot of recent research showing that adipose tissue is a very metabolically active organ, and it produces hormones like leptin and adiponectin that can be related to satiety and hunger. And it also produces a whole lot of proteins called inflammatory cytokines. And these are pro-inflammatory proteins that basically cause an animal or a human that is obese to be in an inflammatory state. And so we have these horses that are obese. They have, this inflammatory response, and we have a whole bunch of other problems that are associated with obesity. So some of these horses that are obese, mares in particular, they can have some reproductive problems where they will not go into their seasonal anestrus. So many of you probably know that a lot of our mares will stop cycling in the winter months due to day length, etc. Well, our fat horses don't do that. And so that really suggests that that adipose tissue is doing something to alter those hormones that regulate our cycles. Horses that are overweight will have heat intolerance. They're going to be less able to dissipate their heat. Of course, if they're carrying around 50 extra pounds or even 100 extra pounds, they're not going to be able to exercise to the same degree. They're not going to be able to run as fast. They're not going to be able to jump as well because they're carrying more weight. We can also see some of these horses develop various types of hyperlipemia, where they can actually accumulate fat within their blood, and that can cause problems for the liver. And then we can also imagine that this extra weight that these horses are carrying can eventually cause some orthopedic diseases. This is much more pronounced, and there's more data in humans, and in particular our companion animal species, where we see increased risks of arthritis. We see some other limb issues in our dogs and cats that are overweight. And so perhaps we'll see as data kind of continues to come in, more cases of navicular in horses that are overweight, more cases of arthritis in horses that are overweight. And so obesity is really not a very good thing. And one of the sort of catchphrases that we tend to use now is this equine metabolic syndrome. And so this is basically a collection of problems that are associated with laminitis. And of course, one of these is an increase in adiposity or obese horses. So many horses that are obese develop this equine metabolic syndrome. Now, some horses that are overweight do not, and some horses that do have equine metabolic syndrome are not obese. But more and more times, horses that are overweight might be also have some of these other conditions that are all sort of collectively going to put a horse at higher risk of laminitis. And so we also see problems with insulin dysregulation, and I'll talk about that in a little bit more, which also includes a condition called hyperinsulinemia. But again, we also see some hypertriglyceridemias, so again, higher fats within the bloods, and we can also see higher concentrations of that hormone leptin, which is actually produced by the fat as well. So all of these, when horses sort of have a few of these different conditions happening, it says that they have this equine metabolic syndrome. And so I just want to sort of identify a couple of these definitions because the terminology is always changing. And in fact, there was a collection of papers and a new sort of consensus statement that came out sort of defining these even further. But one of the terms that we use is insulin resistance. And if we think about what insulin does, basically it works to open the doors so that glucose can get from the bloodstream into tissues that are sensitive to insulin. So for example, our skeletal muscle, if we have blood floating or if we have glucose floating around in our blood, we're also going to have a release of insulin, and that is going to cause glucose to leave the bloodstream and go into tissues such as glucose. Now, in cases of insulin resistance, we have a decreased effect of insulin. So for whatever reason, that key is not fitting in the door, or perhaps that door is stuck and that glucose is not able to get inside. And so glucose concentrations can stay elevated. And so because of this, we can also have other situations where we have a more collective term called insulin dysregulation. And this is really going to accompany all abnormalities of insulin metabolism. So this is going to include insulin resistance, but might also include other situations like hyperinsulinemia. And I'll kind of go through these again in a minute here. So this picture here, this is kind of showing what happens with glucose and insulin. And so we have glucose in the bloodstream. We're going to have insulin. It binds to its receptor, so it kind of puts that key in the lock. And then there's a series of process like turning the key and opening the door that ultimately puts these little vesicles into the cell membrane, and that allows glucose to go from the bloodstream and into the tissue. And so what happens here is kind of shown on this graph on the left. And I want to point out that unfortunately, in a few of my graphs, there are different units. So try to ignore the units to some degree and just kind of look at the patterns. But so here we've got glucose concentrations in this black line here. And so glucose concentrations at rest in a horse are going to be between 80 and 100 milligrams per deciliter, or about 5 millimolar. When a horse eats something that is rich in starch, that starch is going to be broken down, and glucose is going to be absorbed from the digestive tract. And so we're going to start to see an increase in our blood glucose concentrations. When we have increases in blood glucose concentrations, it also triggers the pancreas to release the hormone insulin. So very, very quickly after eating a meal, we can see that those insulin concentrations, which are normally very, very low, are going to start to increase. And as these are increasing, what it's doing is it's causing the glucose to go into the cell. So eventually we see all of this glucose is starting to leave the bloodstream because it's going into the tissues. And because that glucose is going down, that pancreas is going to be less stimulated and it's not going to release as much insulin, and insulin is going to be cleared as well. And so insulin concentrations go down. And so this is what happens normally. When we have horses with insulin dysregulation, we have a couple different things happening. So for example, here again, and so these are different units now. So this is our glucose in millimolar. But here we can see horses that are healthy in the circles. And so this is following an oral sugar test. So they've actually consumed some sugar. And you can see in our normal horses, those glucose concentrations are going to go up. And then over here, you can see this is a big, very different scale. But our normal horses, insulin concentrations are going to go up and they're going to come back down. And again, with the glucose, you can see those glucose concentrations are coming back down because insulin is working properly. In horses that have equine metabolic syndrome, insulin dysregulation, perhaps, we see that that insulin perhaps already starts higher at rest when that horse hasn't even eaten anything. But what happens even more is when that horse consumes even the same amount of sugar as these horses that were healthy, we see a very, very extreme response of insulin. And so we can see these insulin concentrations are getting, certainly several times fold what a normal horse would have. And so these insulin concentrations are getting very, very high. And then what you can also see, though, is that it's not really clearing the glucose. That glucose is not coming down nearly as quickly with those healthy horses. And so because of that, what sometimes we see, the pancreas is going to put out more and more and more insulin. And so that's going to be additive. And so we do see these very high insulin concentrations. Also, perhaps in some horses, insulin isn't cleared properly. And so those insulin concentrations take a longer time to get back to normal. And then even in some of these horses, we wind up having what we call sort of a resting or a fasting hyperinsulinemia, where even before eating or even just after eating a little bit of hay, those insulin concentrations are already a little bit higher. And so this hyperinsulinemia really refers to elevated blood insulin, either sort of fasting. Also, we see these extreme reactions after eating. So these postprandial types of effects, or even horses that are at pasture, they'll always have higher insulin concentrations. Or if we do a test like an oral glucose challenge, we'll see this elevated blood insulin. And then, of course, we also perhaps see this increased secretion or delayed clearance. And that is because we're sort of compensating, because the horse is insulin resistant, the animal's trying to put out more and more insulin from their spleen to try to get rid of that glucose. And so what we have here is sort of this situation where we can have a few different things going on. So we can start here with insulin resistance. And so insulin is not really doing what it's supposed to do to get glucose to go into the tissues. And so that's going to result in those glucose concentrations not clearing properly because we have this impaired glucose uptake. We also have reduced suppression of glucose synthesis, so gluconeogenesis, by the liver. And so normally the liver can produce glucose, and that is actually inhibited by insulin. But if a horse is insulin resistant, that doesn't happen. So we wind up having horses that are hyperglycemic and have higher glucose concentrations. So that's further going to stimulate those beta cells of the pancreas to produce even more insulin. Of course, with insulin resistance, we might also have reduced hepatic insulin clearance, so that insulin isn't getting cleared even more. And because then we've got higher insulin, that actually can go and trigger even more insulin resistance. I always say that it's like living near train tracks, right? So if you live near the train, the first couple of days, you wake up every time the train goes by, but eventually get used to it. So eventually, if these horses are always having these peaks of insulin, eventually it's going to sort of dull that effect. Of course, because insulin has other effects on the rest of the body, in particular with respect to lipid metabolism, again, we might see some cases of hypertriglyceridemia. And so in many of these cases with our obese horses, because that, and the mechanism isn't totally all that well understood, but perhaps some of these inflammatory cytokines can cause some problems and actually trigger some insulin resistance. Maybe it's the types of feeds that we're giving that are higher in starch that sort of have these higher pulses of insulin that can result in insulin resistance. This whole sort of tie between obesity, insulin resistance, hyperinsulinemia, inflammatory, this is all being problematic. And of course, this hyperinsulinemia associated laminitis is this new term. And this is really because insulin has been shown to directly cause laminitis. So of course, this is a study a few years ago now where they actually infused insulin into a horse. And so this is getting to be fairly high concentrations. So if we just go back a couple slides, this is actually going back into these units that I had here. So we're talking, several fold what we got in our horses in these micro units per milliliter. But so these horses were infused with very, very high levels of insulin, and they developed laminitis. You can see even these cellular or these electron microscope pictures where the lamina are all broken down and all sort of jumbled up together instead of that nice fine organization. And so high insulin concentrations can cause laminitis. Another study actually showed that with insulin, horses that had sort of higher resting insulin concentrations also had higher grades of laminitis, so a more severe case. Also, research has shown that laminitis-prone ponies have higher insulin concentrations even at rest. So there's definitely this association between insulin and laminitis. So how does that get back to our pastures? And so again, part of this is because if a horse is eating a lot of pasture, they are going to be obese. And so we get this association with obesity. But also we have to remember that that pasture can be very high in non-structural carbohydrates. And non-structural carbohydrates are essentially our starches and our sugars that when digested are going to be broken down into primarily glucose, which then it goes into the bloodstream and increases blood glucose concentrations and insulin concentrations. And so we can have this type of thing happening. So these are looking at insulin concentrations in horses that were grazing versus horses that were just fed hay. And so what you can see here, and this is going over the time of the day, so earlier in the morning, we can see that horses had higher and higher insulin concentrations sort of later and later in the day. Overnight, they went down and they continued to go up again. And so part of the mechanism for this is based on how plants produce sugars. And so we know that plants use photosynthesis. They use the sun and they produce sugar. And so as those plants are hanging out in the sunshine, they are producing more and more and more sugar. And so horses eating these pasture are going to be consuming more and more sugar as that day goes on, as those pastures accumulate. Overnight, photosynthesis stops, and those carbohydrates are actually used by the plant to help them grow. And then, those glucose concentrations in the plants are going to go back down. And then horses grazing at night, are going to be consuming lower levels of carbohydrates. And then once it gets sunny again, they're going to be consuming higher concentrations of sugar. And so again, those insulin concentrations are going to get higher and higher. I also want to point out again that these are still not super high insulin concentrations. They're elevated, but in a normal horse, this might not be that much of a problem. But if you went back and we had this horse here where even just the same amount of sugar caused, certainly an increase in glucose and then this much of an increase in insulin, you can see that it could be pretty substantial for our horses that might already be at risk. We also have a problem with non-structural carbohydrate overload in the hindgut. And so basically when horses are digesting starches and sugars, primarily those are going to be broken down within the small intestine by the enzyme amylase. And amylase is going to break apart most of our sugars, and hopefully those sugars are going to get absorbed. And I'm sorry, my picture here is covering some of my wording. When the horse appears to have an upper limit to how much starch that they can digest and how much sugar they can actually absorb. And so if horses are eating a lot of sugar, so for example, lush pasture, or even they get into the grain bin and eat half a bag of feed, they are going to be consuming so much carbohydrate, so much simple carbohydrate, these starches and sugars, they're going to overload the small intestine, and then these are going to get to the large intestine. Whoops. So within this large intestine here, this is where we have our fermentation vat, all of these billions of microbes that horses use to primarily ferment fiber that's found in hay. Suddenly, they get access to starch, which is fermented very differently, and it is going to result in the production of some acids that are stronger acids than what are normally produced back in that hindgut. And so we can have higher concentrations of lactic acid production. And ultimately, we can have a decrease in the pH, so an increase in acidity within that large intestine. And that increase in acidity can impair the mucosal surface of the intestine. So it can actually sort of break down that robust layer between the inside of the digestive tract and going inside of the horse. We have a very good system normally with that. The mucosal surface is usually really good at preventing bad stuff from getting into the horse unless it's a nutrient that's absorbed. But if you have an acidic stomach, sometimes those are broken down and we can have things get absorbed that shouldn't be absorbed, like perhaps some toxins. And so that is another model where we can have some laminitis development, where we have a high starch and sugar intake very, very quickly. And so that can be another way that laminitis could potentially develop. And so when we have a higher risk of laminitis, it's because we've got these at-risk horses. We have horses that are perhaps obese because they've been overfed at pasture. Maybe they have equine metabolic syndrome because they've got some other things going on. Perhaps some horses that have Cushing's disease might also develop EMS. We have some insulin dysregulation. Horses that have had laminitis previously are always going to be more at risk. And then perhaps we have what I call a trigger event, where horses are going to consume perhaps too much carbohydrate. They get into the grain room. They overdo it on lush pasture. And so that's going to be perhaps a double whammy, where we're suddenly getting huge increases in soluble carbohydrates like our starches and sugars rushing into that hindgut, but we can also get some of those starches and sugars being broken down and causing big increases of glucose in the blood, and followed by huge increases in insulin if that horse does have some insulin dysregulation. If a horse develops colic and they have some colitis, and again, that's inflammation where that can cause some additional toxins to be released, any other types of sepsis or toxicity, all of these can be sort of a trigger event for laminitis. And so what I like to say, if you ever watch The Price is Right, they have this cliffhanger game where when you go and you shop all of your prices, you get higher and higher on the cliff, and then eventually you fall off. So I like to think about a series of risk factors for horses, whether it's just genetic, because you have that type of horse that is a very easy keeper. You might have a horse that's obese already. You might have a horse that's got Cushing's disease. Maybe they've already got some insulin dysregulation. They've got hyperinsulinemia. They've got some symptoms of EMS. And then whatever is that extra trigger event is what causes the laminitis. So you can have horses that are obese and they seem fine, and then they go out at pasture, or then they get into the grain bin, and that's what sets the cascade over into potentially detrimental effects. So what can we do to manage pasture to prevent laminitis? First off, don't let your horses get fat. Monitor the diet, monitor their body condition score, monitor their body weight, take measurements, take pictures, increase their exercise, do everything you can to stop getting your horses fat in the first place. Also, potentially limit the non-structural carbohydrate intake. So that includes potentially limiting your pasture, but it also includes testing your hay, looking at your concentrates, and looking at the non-structural carbohydrates in these. And if you have a horse that is in sort of one of these at-risk categories, you probably want that whole diet to be less than 10% non-structural carbohydrates. Also, we don't want to allow this excessive pasture. We don't want them to have this buffet. We don't want them to be out on very rich sugars. So that's another thing that we would really want to do to limit, to prevent laminitis. If you have a facility that does not allow you to prevent pasture, use a grazing muzzle. Don't let them out for 24 hours a day. Perhaps limit the pasture size so they can't actually eat all that much at once. So again, if you've got a horse that's obese, you want to do some weight loss strategies. Again, Dr. Burke is going to talk about this a little bit more next week. But monitor or avoid pasture, again, because this is this buffet. We can monitor our hay, test for that non-structural carbohydrate content. If you do find your hay is high in non-structural carbohydrates, not all is lost, you can soak it. Soaking is very effective at decreasing the non-structural carbohydrates that are in hay. And because it actually gets rid of sugars, it also reduces the calories. And so that could be also beneficial for horses that are overweight. You don't necessarily need any fancy contraption. This is kind of the type of thing that we do where I like to actually have 2 tubs. One of the tubs has got holes drilled in the bottom of it, and that sits in top of the other. And then you pour water into it, you let it soak 30 minutes, and then you pull that top tub out. All of the water drains out of the holes, but the hay is retained. And then you can place that into your horse's stall, and he gets some nice sugar-free hay. And then, of course, you want to toss that water. Don't go and feed it to your horses because that's high in sugar. We can also be very careful about their total feed intake because that's going to be relevant to how many calories they're consuming. So you should be looking into weighing out their hay and feeding them maybe 1.5% of their body weight. You might even need to go lower than that. I don't recommend going lower than that unless you have a veterinarian who's working very carefully with you, because there are some problems that can arise if you've got a horse on a very strict and severe diet. Again, these non-structural carbohydrates, the NSC, this term that I'm using, is the sum of this water-soluble carbohydrate and starch. And so in this sample here, it would be 7.8, which for hay, that's probably really good to begin with. If you have a really sensitive horse, you might still go and soak it a little bit. But this is really the importance of getting your feeds analyzed, your hay analyzed, so that you can see these values. And not all labs will test for these extra carbohydrate fractions, these water-soluble carbohydrates and the starches. So you might need to go shop around and find a facility that will test those. Because again, these are going to contribute to blood glucose that could potentially contribute to a sort of hyperinsulinemic type of response. Again, ideally, total NSCs, if you get some grains in there, it's less than 10%. But if you have very sensitive horses, you probably want to get lower than 10%. And it is very possible to be able to go and do that. Just to compare some different types of feeds. So if you're looking at different type of hay that you might want to look at, they might have different types of sugars. And so of course, if we look at our pasture, it can be quite high. And these are sort of values that are on average, but you can see that these can be certainly higher than what I might say is 10%. But then you can also see some other feeds that are quite high. You know, different types of hay that might be higher than others. Oat hay, barley hay, because they usually have the grains still associated with some of them, they can be quite high in non-structural carbohydrates. So you might want to be a little bit careful. Again, control or limit the pasture intake. Avoid the pasture altogether. That would be the best thing that you can do. Grazing muzzles, again, Dr. Burke is going to speak about this in 2 weeks, or next week, I guess, next week. You can also limit the size that they have. Again, so by limiting the size, you're limiting how much pasture is available. And if you have enough horses on there, they might sort of eat it all up, and then, you know, they might not be able to, it sort of self-limits themselves a little bit if they don't have as much time out there, enough size out there. Again, we want to try avoid grazing during these peak times. So this is the data I showed you before. And this was from another study that we did where these were horses that were turned out at night. These were horses that were turned out during the day. And then these were, the green is the horses that were out for 24 hours. And so you can actually see here that the horses that got turned out at about 8 o'clock, they basically went out and gorged on pasture that had been sitting in the sun and developing sugar content throughout the day. And so they were able to go out and gorge themselves. And ideally, the best time to actually turn your horse out would be very early in the morning, after those carbohydrates have kind of come down throughout the day and before they start to develop throughout the day. I do want to point out, though, that certain times of the year, like when it's really cold at night, but it's sunny during the day, we can have situations where it's so beautifully sunny, there's a lot of photosynthesis, but then at night it's too cold for these plants to grow because they're dormant. And so in those cases, some types of pasture will actually accumulate some sugars. And so, for example, this is showing the non-structural carbohydrate in tall fescue. And you can see that in sort of these spring types of months where it can be very sunny, but perhaps still cold at night. And then also into the fall, we can see that those carbohydrates can get relatively high. Meanwhile, in months where those pasture for full season grass, it's going to be fairly dormant in the summer months. And so those are going to be fairly low. And again, a lot of this, and I say this time and time again, this is tough love. These little show ponies that look so cute are actually at significant risk. And I say that repeatedly. We do not want horses to look like Thelwell ponies. And this is a big problem within the show industry. I've published a recent article that was looking at the sheer amount of overweight ponies that are at very high level events in the United States. And these are all going to be at risk. Ponies already are at risk for developing laminitis just because of their genetics. And so we certainly don't want to see fat little ponies where you can't even make out their shoulder and their necks are all fat. This is a study that one of my graduate students did, and basically she looked at weight loss in horses when the owners were given dietary strategies, like individual strategies for each of their horses. And then we went and surveyed the owners about what they actually were able to do. And the horses that were able to do things like get their horses off the pasture, the ones who weighed their horses' hay every day, who soaked their hay every day, who had a lot of compliance, these are the ones where we actually saw some weight loss. The ones who didn't change anything, of course, they're not going to, those horses aren't going to lose weight. So it really is a situation of tough love. But of course, it's far better than the alternative, because any of you who've ever seen a horse with laminitis, you know it is dangerous and awful and painful. And not something that anybody wants their, perfect ponies and lovely horses to have to go through. So pasture can be great, but let's, manage it properly. So with that, thank you. I don't think I've gone past my time. And I'm glad to answer any questions at the end of all this.
Awesome talk, Dr. Pratt-Phillips. Thank you so much. And yes, the questions are just rolling in. So I've been busy trying to compile them, figure out which ones are the most popular, and then go from there. So I think one of the things to first, I guess, clarify, because yes, your title was all on pasture, but you did talk a lot about hay. So can you comment about when you're talking about amounts of pasture versus amounts of hay? Are you talking about the same thing?
That's a great point. So when I'm talking, and some of the slides I kind of alluded to in terms of the pasture intake and that sort of average pasture intake. So those were on a dry matter basis. So when we think about hay and you look at your hay and it's all dried up and crusty, and you look at your pasture and it's all beautiful and lush, and that's because it's still got water in it. The whole point of making hay is to allow that water to evaporate and dry out so that it can be preserved as hay. And so the water content of pasture can be, anywhere, there could be 70% water in pasture. And then with hay, it's only going to be maybe 10% water. And so when we're talking about the amounts of hay that a horse might actually eat in terms of pounds, a horse might eat, say 20 pounds of hay, but they might actually eat 100 pounds of pasture. And so we're really talking about, it's not apples to oranges type of thing. But when I was looking at some of those graphs that were showing the non-structural carbohydrates in some of these different types of plants, those were represented as on a dry matter basis. So again, taking all of the water out of them and showing them as on a dry matter basis, so that we can actually compare different types of feeds, including pasture and hay. Thank you, Carrie. That's an excellent point that I should have included.
No, that's great. And that kind of segues into another one. A lot of people ask, how do they know what NSC is in their feeds? And I briefly mentioned to some of them that, if it's advertised on a feed label to be a low NSC feed, it should say, but what can you comment about how they figure out what's in their pasture and their hay?
Yeah, so the best thing to do is to have it tested, and it's really, really easy to do it. So ideally, you contact your extension agent like Carrie or whoever, whatever state you might be in, and even county agents can come out, and if it's hay, they can have a special device called a hay core sampler. Basically, it's just a big drill, and it goes into the middle of the hay, and it's supposed to get a very good representative sample of the hay. And so ideally, they would go and select a bunch of different types of hay, and then they would take this and sort of put it all together and then send it off to a lab. With Pasture, you can kind of do the same thing, where what you would do is you'd have a pair of clippers, and you can do a representative walk around your pasture. So you can say, all right, every 4 steps, I'm going to take a pasture clipping. And you kind of zigzag and walk all over your field so that you can get a representative sample. You want to try to even watch what the horses are eating, try to take the plants that they're eating, take the collection down to the height that they're eating down to. And that would be a good representative sample of the pasture that they're eating. And then again, you should shove it into a plastic baggie and send it off to an analytical lab. I really like Equine Analytical in Ithaca, New York. I don't work for them. I don't make any money from them, but they do a very good analysis that's relatively economical. And what I like best is they also provide a database. So you can actually go and have your hay or your pasture analyzed and then compare it to other pastures from your own region or from across the country. And so it's a really helpful tool. And so I really value that service that they provide.
Yeah, great. Thank you. I got several of these questions asking about what's the difference between nice, long, really tall, lush pastures versus mowed, overgrazed, or just short pastures in general.
So that's a great question too. And Dr. Siciliano, my colleague here, is probably the better person because he's done quite a bit of work on it. And I actually had some that I took out too. But so in theory, if a plant is growing actively, it is going to be using sugar. And so in some cases, when sort of heavily mowed hay has been tested, it can be lower in sugar because they're always sort of turning it over, that grass is constantly growing. Sometimes when horses, but then it also comes down to the sward height itself, because there's also a situation where if you've got very long pastures, then a horse can take a whole big mouthful and be able to eat some of that much more quickly. So even if it might have, perhaps, well, and then as that plant gets taller and taller too, it develops more fiber within it. The plant is going to be more mature. So essentially it's going to be less lush the taller it is, but horses can still eat it because it's so big and it's easier for them to consume rapidly. So I don't know if there's necessarily the best height for it to be. Ideally, in terms of good pasture management, we want to be grazing with the golden rule of grazing is you want to graze pasture when it's about 6 to 8 inches tall, and then take it off when it's sort of 2 to 3. But there might be some differences that you might do if you've got a horse that is, really at risk. Maybe you don't want to have anything too high. That's a way to actually limit the amount of pasture that they can consume by mowing it down and keeping, that total herbage that they can get from there lower.
Yeah, that's great. And with the number of questions we have here, I think we could go on for another 3 hours answering all of those. But for the sake of time, if Dr. Pratt-Phillips might have time to peek in the Q&A and see which ones we might not have answered, that would be awesome. But I think we're going to move on, and we will ask Dr. Kristine Urschel to come on and share her screen, and I will give her a little bio. So Dr. Kristine Urschel is an associate professor at the University of Kentucky. She's originally from Alberta, Canada. Wow, I didn't realize we had so many Canadians on this call. We got all the Marylanders next week, so that's great. Dr. Urschel has completed a Bachelor of Science in Agriculture with a major in animal science, followed by a PhD in Nutrition and Metabolism from the University of Alberta. Following her PhD, she completed a postdoctoral training in equine nutrition at Virginia Tech, and that is where we overlap just a little bit. So Dr. Urschel is now accepted a faculty position at the University of Kentucky in 2008. Dr. Urschel's research program focuses on protein and amino acid nutrition in horses across the lifespan. She has also particular interest in regulating muscle protein synthesis, and she was a recipient of the 2021 ASAS ESS, which is the Equine Science Society, award for her research in her program. She is, in addition, to her research, she teaches undergraduate classes in physiology and advises students in animal and equine science. So welcome. Thank you, Dr. Urschel. Go ahead and take it away.
All right. Thank you so much for the introduction. And yeah, I guess you guys got Canadian content tonight from Canadians that live in the US. So another interesting thematic similarity. So there we go. So I'm going to start just quickly with the take-home messages so you get some idea of where we're going. And then, spoiler alert, this will also be the last slide. So by the time we get to the end of this talk, or what we're going to do throughout this talk, is talk a little bit about skeletal muscle in horses, and particularly the importance of protein in skeletal muscle. And then we'll follow up with spending a lot of time on the different things that can influence the process of muscle protein synthesis. And then just something to think about as we move through all of this is understanding some of the factors that regulate these pathways. We might not be quite there yet with some of the research and some of what we definitively know, but it gives us clues as to things we might be able to do as individuals that feed horses or individuals that manage horses to help promote muscle mass, to either gain it or maintain it throughout the lifespan. So in terms of body composition of horses, your typical horse, probably the majority of their body weight is made up of muscle. So in one study where they actually did body composition in horses that were deceased and actually looked to see how much muscle there was, somewhere between about 40 and 55% of their mature body weight could be was accounted for by muscle, with the more athletic horses having a greater percent of body weight. So that 40% range in a mature horse is probably the ones that are fairly obese and have a fairly significant percent of their body weight as fat. So then when we look a little bit deeper, we can see that muscle is mostly water, just like everything else in their bodies. But if we take the water out of the picture, about 2/3 of the non-water composition of muscle is protein, with then the remainder of it being fat, glycogen, so glucose stores, vitamins, and minerals. So protein is definitely a very important component of muscle. And so I like to use this slide here because it shows or kind of gives us an indication that muscle mass, because protein is such a major constituent of muscle mass is ultimately determined by the balance between the rate that protein is made and the rate that protein is broken down. So even in your mature horse that's presumably, weight stable, they're not gaining or losing weight, their muscle amounts might be remaining fairly constant, their muscle protein pool is still a very dynamic pool. And what I mean by that is at certain points in time during the day, they're actively making protein in their muscles. So an example would be following the consumption of a meal. For a period of time after the meal, the muscle is actively making new proteins. But then at other times of the day, say if you have a horse that's in a stall overnight, maybe where you feed them their last grain meal, maybe early evening, and then they don't get another grain meal until 12 or 14 or 16 hours later, towards the end of that period, they're going to be more in a protein breakdown state in their muscle. And as long as sort of in general, the rates of synthesis balance off the rates of breakdown, their muscle mass isn't going to change. The amount of protein in their muscle won't change, but the protein is constantly being made and broken down. It's not that once the protein is made, it's there forever. It's a very dynamic pool. So as a result, it's really the balance between these two processes that we care about. So over time, if we find that there's more synthesis going on than breakdown, over time, they'll make more protein, they'll have a net gain of protein, and as a result, their muscle mass will increase. On the other hand, if you're consistently finding that this side of the scale, so the protein breakdown side is predominating, over time, you'll have a net loss of protein and a net loss of muscle mass. So these rates can be affected by any number of things. So the horse's age, perhaps some of the medications they're on, physical activity, hormones, disease or illness, and nutrition. So all of these factors can affect both protein synthesis and protein breakdown, but research, particularly say in rodents and humans, have found that the protein synthesis side of this equation seems to be far more responsive to sort of being able to be turned on and off in the short term by these variety of stimuli. And so most research has focused on the regulation of protein synthesis, but this is not to say that some of these factors won't affect protein breakdown as well. I'll primarily be focusing on the protein synthesis end. So before we get into that, just a brief review maybe of your high school or college biology. So what is protein? At the simplest level, protein is a chain of amino acids, and there are sort of 20 traditional amino acids that make up protein, and then you have selenocysteine, which is kind of incorporated in a slightly different way from sort of the typical 20 amino acids. So in mammals, there are 21 different amino acids that are found in protein. And these amino acids get added together by forming peptide bonds, and you get a chain of amino acids. The order of those amino acids is ultimately dictated by the animal's DNA or genetic information. And I'll talk about that a little more on the following slide. So once we have this chain of amino acids, it then gets folded up three-dimensionally into the final form that you might see here. So the solid parts are the actual chain of amino acids, and then you can see that there's like twists and turns and it folds back among themselves. So this particular protein here that I've used as an example is hemoglobin. So it's the major protein in your red blood cells that carries oxygen around your body, but all proteins in the body. So like the actin and the myosin and the muscle, the various enzymes that do the reactions in your body, all of the proteins in your body are going to have a three-dimensional structure. And some of the things that dictate the three-dimensional structure is going to be the specific sequence of amino acids that make up that protein. So what do we need to make protein? Or what does the process of protein synthesis involve? So ultimately, we need to convert the genetic information. So the DNA needs to be transcribed into mRNA. So that's providing the blueprint to make the protein. It's got the series of kind of three different base pairs, and then in groups of three, they correspond to the different amino acids, which can then be translated into protein. So we need to make protein, first of all, we need the blueprint. So what mRNA gets made from the DNA, and that's determined by processes that go on in any given cell's nucleus. Once we have the mRNA, so that's this sort of pinkish chain here, we then need to read that code by assembling all sorts of cellular machinery around it. So the ribosomes are this cellular machinery. So they are components that are actually able to add those amino acids to the growing protein chain. So we need to assemble that machinery. And then we also need what I call the ingredients. So we actually need to have adequate amino acids to actually form the protein. And then the last factor associated with all of this is the process of making protein is a very energy demanding process. So it costs energy for every single amino acid that gets added. And so we also need to make sure that our horse has adequate dietary energy in order for this process to happen. In terms of what I'll be talking about today, my research and the data I'll be presenting most closely relates to getting the equipment assembled around the mRNA, and that's regulated by a signaling pathway called the mTOR signaling pathway, which I'll be spending a lot of time talking about and giving examples of. And then we also in the diet need to make sure that our diet provides an adequate source of the building blocks, which in this case are amino acids, and specifically the essential amino acids, which are those amino acids that the horse's body does not have the capability to make from scratch. So this mTOR signaling pathway is a pathway that I've been working with or on now for I guess about 15 years. So I started with this at Virginia Tech, and my research has always had a component of this throughout my time at Kentucky as well. So there's a lot of complicated things here and a lot of complicated acronyms. But the key is we have different stimuli, for example, insulin, exercise, amino acids, through different signaling pathways in the cell. They can independently activate this central protein here in blue, which is called mTOR. When this pathway gets activated, or when this protein here gets activated, it can then go on and activate other molecules. For example, this protein here, as well as this protein here, or this phosphorylate, this binding protein here. What these exact proteins don't necessarily matter for the purposes of this talk. But at the end of the day, when these various proteins get phosphorylated, the ultimate end result is you get the assembly of that machinery around the mRNA. And so the cell is able to get the mRNA converted to protein. So it's getting the equipment assembled that, assuming you then have adequate amino acids, means that the protein can be made. So studying this pathway gives us an indication of whether or not you're going to see an increase in muscle protein synthesis. So as I mentioned, the three key things, and this is from like before we even started doing this in horses, we knew from rodents, we knew from humans, from pigs, that these seem to be some of the big factors that activated this pathway. And you can see they all act on it in different ways. And I'll give some examples as we go about why the fact that they're independent pathways might be important as well. So now we're going to start into some of this research that we've done in horses. So I'm going to start first with data that we got from mature healthy horses. And you may ask, mature horses, they're presumably, muscle stable. We, in a lot of cases don't necessarily care if they're gaining muscles so much as they're not losing muscle. But we started a lot of our research more as proof of concept in mature horses because we didn't need to take into account maybe some of the additional factors, such as their growth rate or the disease process, which, as I mentioned, can influence those pathways of protein synthesis and breakdown. And as I mentioned earlier, even in a mature horse that isn't necessarily gaining or losing muscle, they still are constantly making muscle protein and breaking it down. So we can still study these pathways in this age of horse. And so what we usually have done is provided some sort of stimuli, and I'll explain those specific to the studies as we go. And then a certain amount of time after that, we collect a muscle biopsy, or we perform a muscle biopsy, which is what Nicole here, one of my first undergrad interns, is doing. So we use this Bergstrom needle here, and we go through the skin and we collect a sample. We typically use the gluteus medius muscle because it's a hind end muscle, so we know it's important for locomotion, but it's also fairly easy to get a pretty consistent placement of the sample each time, which can be important when we're trying to compare things between horses, that we can consistently hit the same muscle group every time. So what we do is we get a muscle sample and then we prepare it for what we call Western blot analysis. And what this analysis does is we can separate out the various proteins based on their size, and then we incubate it with antibodies that are specific for just our protein of interest. And as you'll see on some of the slides, we get essentially a band on a gel that corresponds to the protein of interest. And then we can look at which conditions result in darker bands. So our very first study was just looking at, and again, it was a proof of concept type study, but looking at how does feeding affect the activation of these pathways. So we had horses and we either, or in both cases, we withheld feed for 18 hours. And then for some horses, we refed them. And for the other horses, we kept them in like a post-absorptive or a fasted state for another 90 minutes. And then 90 minutes after feeding, we collected a muscle sample. And so these are two of those proteins. And in these cases, phosphorylation is indicative of activation of those pathways. So a status that's going to be pro-protein synthesis would be what we have here. And you can see that as we expected, following feeding, these pathways were upregulated. So there was an increase in the activation of these pathways, which is what we expected based on the other literature, but we needed to figure this out as a first step before we moved forward in horses, just to sort of see where they're at compared to other species. So this was the very first study we did in horses looking at these pathways. The second study that we did was looking at how sensitive these pathways were to insulin. Again, in healthy horses. I'll present some data later on where we maybe looked at some of this data in horses with insulin dysregulation, like Dr. Pratt-Phillips spoke about for quite a while earlier today. And what we found in this study is we infused 4 different rates of insulin into these horses. So either no insulin or a low, medium, or high amount of insulin. And what we found was that for each of those various proteins in the signaling pathway, you saw an increase to a certain point in how much activation you could get. So what that told us is, again, just like in humans, just like in rodents, these signaling pathways are sensitive to insulin levels. It does appear, though, that this response can be saturated. So at a certain point of insulin concentrations, you did get to a point where the activation of those pathways are maxed out and no additional insulin resulted in an increase in activation through those pathways. So then kind of at the almost opposite end of where we're at are some of the more recent studies that was done by my postdoctoral associate, Dr. Lose, who did some really cool stuff during her postdoc that was looking at some of the questions that, as we did other research, which I'll present later, we started to get some questions of, well, why are we feeding this amount of protein as our challenge? And some of it was more along the lines of, well, we wanted to make sure initially, like in that fast and refeed study, that we provided enough protein. And then because it worked and gave us a nice postprandial response, we just went on and always used that dose of protein because we knew it was enough to activate those pathways. So she kind of helped with this study take us back and help us look at, well, how much protein do we need to maximize the activation of these signaling pathways? So in her study, what she did was we studied horses 90 minutes after receiving different intakes of protein. So no protein, so just, again, like our fasted group in that earlier study, all the way up to about 0.5 grams of protein per kilogram body weight. And so a bunch of intakes in between. And she found up into about 0.25 grams of protein per kilogram body weight, we had sort of a linear or a dose responsive relationship, regardless of which protein we looked at. So we only looked at 2 of those mTOR related proteins in this case, but they both seem to agree that it increased to a point and then the response seemed to level out. So in this case, which was a pretty high quality protein, and that'll become important when I show you some of her data from a follow-up study that she did after that, that it seems like we can at least maximize the mTOR signaling. Now, a caveat there is, and something to keep in mind as I'm going through all of this data, is mTOR signaling really just tells us about how that machinery gets assembled around the protein. So how, I guess, prepared the cell is to make the protein. It doesn't actually tell us, did that protein get made? Because that's going to depend on, do we have enough amino acids? Is there enough energy? So I'll discuss some of the implications of that later on. So keep in mind here that this data doesn't tell us that protein synthesis gets maximized here, just that those pathways seem to get maximally stimulated at this level of intake. So in a series of follow-up studies, and this is a study that was part of a bigger study, and so I'll be discussing the data from it in a few different places. But another interesting finding that she had a couple years later relates to the fact that not all dietary protein is the same. So when you go to the feed store, you look at bags of feed, there's all sorts of different ingredients when you buy a bag of feed. And, you know, some of those ingredients are more related to the energy component of the diet. Others are more related to the protein component of the diet. So with regards to the protein, some of your feeds might be more of, say, a forage-based protein source. That's certainly true if your horse is primarily grazing, is getting most of their dietary protein from pasture or hay, versus horses that might be getting fairly large amounts of a concentrate feed. So, you know, maybe a ration balancer that might have 30% protein, or some of the other feeds that might have 14 to 16% protein. And based on what the major protein source is in the feed, that'll dictate how easily the gastrointestinal tract can digest that protein, which could have implications on the absorption of the amino acids. And because the protein all differ in their sequence of amino acids, for example, protein that comes from soybean meal is going to have a different sequence of amino acids that it provides than, say, alfalfa meal or a more forage-based protein. So not all dietary protein is the same. And so in this study here, we had mature horses, and we studied them after we fed them equal amounts of protein, but with the major dietary source of that protein being either more soybean meal based, so a pretty highly digestible form of protein that we know to be primarily digested and absorbed in the small intestine, or an alfalfa meal based supplement, which is more likely to be digested, or greater amounts of it aren't digested until the large intestine. And so what we have, or what I've shown here, are the different concentrations just collectively of dietary amino acids and how they're absorbed. So this is collectively looking, and sorry, my cursor is working very poorly. The essential amino acids are on this graph, with the alfalfa-based protein being the colored in shapes, and the protein supplement, so the more soy-based proteins, being the open triangles. So these are the essential amino acids. This is leucine, which seems to be an amino acid that's a little more, you hear about it more in the supplement business, and I'll explain why a little bit later for some of that. But we did single out leucine, as well as the non-essential amino acids. And you can see that no matter which group of amino acids we looked at, we definitely got higher levels in the blood following feeding when horses received this amount of protein here in a soybean meal-based protein versus in alfalfa meal-based protein. So that's presumably due to different digestibility, as well as probably to some extent different amino acid composition. And sure enough, when she then went on and looked at the activation of these signaling pathways, she found that the the protein supplement protein, so the one that had more soy protein in it, also resulted in a higher activation of some of these signaling proteins, particularly at the 90-minute post-sampling. So another interesting thing that we did as a part of this study that was a little bit of our sub-objective was we took muscle samples at various time points after feeding. It's something that we'd never done in any of our earlier workup. We'd always had good success with the 90-minute sampling, and so we kind of had always gone with it. But where we had, as one of our hypotheses of this study, was that the alfalfa-based protein would probably have different kinetics of digestion. We didn't want to miss when it might peak post-feeding, that maybe because it was more slowly digested, we might not see its peak till 180 minutes or even later. We wanted to take different samples. But what we did find is it seemed like no matter which protein we were studying, you sort of saw maximum activation of these pathways about 90 minutes post-feeding. And so that 90 minutes might be important too, as we talk about trying to coordinate some of these pathways together, different ways to activate, knowing that there seems to be a range of time when you have the greatest activation following a meal. So that's some of the work that we did in mature, healthy horses. Now I'm going to go through some of the different work we've done in different sort of special groupings of horses. So the first I want to talk about briefly is our growing horses. And so with the information on this slide, I just want to emphasize that when horses grow, we know that they gain body weight. So we know that from birth to a year to the time they're mature, their body weight increases dramatically. But not only that, compared to birth, not only do they get heavier, but a greater portion of their body weight is accounted for by muscle. So for example, in a newborn thoroughbred, they might about 35, 36% of their body weight is muscle. And by the time they're mature, if they're a really athletic horse, not only are they heavier, but then a greater percent of that heavier body weight is muscle. And so to gain that muscle, they need to gain a lot of protein. And similar can be seen in the French draft breeds, where at birth, they're about 36% muscle. And by a year of age, their body weight is increased, and also a greater proportion of their body weight is muscle. And so that muscle, to gain muscle, they're also having to gain protein. So that scale is shifting more towards protein synthesis predominating over protein breakdown. So in our first study really the only study that my group has done relating to these signaling pathways in growing horses, is we did something that was very similar to that initial study where we had horses and we studied them in a post-absorptive state, so fasting, and then 90 minutes following a meal. And we found basically for all of the proteins that we looked at, regardless of age, there was an increase following feeding compared to when they were in the fasted state. But more interesting was that the yearlings seemed to be, so the younger growing horses seem to have a much greater increase in response to feeding than even our 2-year-old horses had. So here the yearlings, it approximately doubled, whereas our 2-year-olds, it wasn't nearly as much. For this particular protein that we studied, it more than doubled, whereas for our 2-year-olds, we didn't really see any sort of activation. And same with this protein here. So it seemed that the muscle of growing horses is more sensitive to this anabolic stimuli. And that's probably why when horses are younger, they're able to put on muscle so readily. Same with humans. We gain muscle pretty easily when we're growing. And then when we get older, we have to work a lot harder to build the muscle. And it's probably because we're less sensitive to that stimuli. So as I said, we haven't done a ton of this research in growing horses, but some other interesting questions or some other things to consider are the fact that if muscle is most sensitive early in life, what happens if there's disruptions in feed intake early in life? Say a situation where maybe either a horse has been starved or has had an illness that has long-term resulted in a disruption of feed intake. So maybe they miss that window where their muscle is really sensitive to feeding. Do they make those gains up later on if, we refeed them or they pick up their feed intake? The other thing is while, our yearlings aren't in necessarily a lot of formal exercise, there are some sort of controlled hand walking type exercise we might do with a young growing horse, and even a horse that's maybe 2 or 3 and starting in their athletic training, where exercise is one of the other things that activate those pathways. So how can we maybe combine feeding and exercise to ensure that we're maximally or optimally stimulating these pathways? So not things we have answers to yet, but interesting things to consider. So now let's skip to the opposite end of the spectrum, because that's another group of horses where muscle protein is really interesting. And so at the opposite end of the spectrum, we have our old horses, which is associated with a condition called sarcopenia, which is an age-related loss in muscle mass. And it's been described in horses as well as humans and other mammals. Now in humans, we can quantify this muscle loss a lot easier because we can use different imaging techniques and different maybe body composition measurement techniques that are logistically easy enough to do in humans, very, very difficult to do in horses. And so we're more reliant on more qualitative methods to assess muscle mass. But surprisingly, up until very recently, there wasn't a good system in place like we have the body condition scoring system. We didn't really have a good system in place to quantify muscle atrophy or muscle loss. And so I had the opportunity to work with a PhD student in Dr. Amanda Adams' lab, Dr. Elisa Herbst, who is now actually part of the Rutgers team. And as part of her PhD research, she designed a muscle atrophy scoring system with the goal of applying it to old horses and being able to maybe use it as a tool to monitor changes in muscle mass over time, and to try and put something at least semi-quantitative to something that we've always kind of really depended on, just more descriptive stuff. And so she worked up, and this is a publication that she just got it published last year, where she developed this scoring system. And then she applied this scoring system to horses with a wide range of ages. And what she did find is that age in horses was associated with old age was associated with higher muscle atrophy scores in some of the areas that us as horse people do associate with loss of muscle mass. So, the back, where they get a sway back, or hind end muscle atrophy. And then in a different sort of sub-study within this study, she also found that horses with PPID, so what used to be known more commonly as Cushing's disease, those horses had higher muscle atrophy scores than aged horses that did not have PPID. So she's finally, helped us put some more quantitative measures to say, well, we've always sort of known for years, which is that old horses seem to lose muscle mass. So before she had this scoring system in place, we're going to jump back to some of my older research, which is now, 10 or so years old. And in this study, we were also interested in comparing the activation of those signaling pathways in old horses. So they were, a little bit over 20 years old compared to mature horses. And in this case, we saw that one of those factors did seem to be less activated in our old horses than in our mature horses. Now, the one caveat that I will put on this is there's some of these studies, and quite a few of these studies now as I go through them, now that we've done more of the studies like Dr. Lose's study with, what optimal level of protein intake should we feed that will tell us something about that sort of maximizes this response. Some of these studies probably now need to be redone because we know more about the pathway. In this study, we studied these horses in the fasted state. So what we don't know is maybe if we had provided them with feed, what these differences might have looked like. Maybe they're more pronounced, maybe the differences disappear. But in this initial thing, there is at least some evidence that the aged horse might have less responsive pathways that regulate muscle synthesis. We also did a similar study in horses where we compared age-matched horses. So these were all aged horses, and we compared healthy aged horses, so horses without PPID, to horses with PPID. And in this study, we almost kind of went to the opposite end of the spectrum. So we fed them a lot of protein in a single meal. And interestingly, we didn't see any difference in the responsiveness of these two groups for any of these signaling pathways. This one was getting close. So it's possible we had relatively small sample sizes here. So maybe if we'd used more horses, we might have seen a significant difference in the activation of this one particular protein here. But then as I was reading back through this paper the other day, trying to get ready for this talk, I came across some of the discussion that we'd said where at the time when we did this study, neither group of horses, even though we'd fed them a pretty large meal, we didn't actually see a post-feeding increase in plasma amino acid concentrations. And the feed that we gave to these horses at this time was an alfalfa meal-based protein, where we now know from some of our more recent work results in a much lower activation of these pathways. And so it might be, if we were to repeat this study again, but with a more soy-based protein, that maybe we are able to see differences in the activation of these pathways between groups. And it might be that one group is more responsive to the other. Alternatively, again, sometimes when you're doing research in populations of horses, you're at the mercy of a little bit of the horses that you have. In our case, these PPID horses that we used in this study were PPID horses that were able to live in a group housing situation. They weren't being treated with pergolide or anything. So they were pretty low maintenance PPID horses. So we may have also just selected for a group of PPID that maybe don't actually have muscle atrophy, because we also know that not all horses or aged horses with PPID present with muscle atrophy. So Lots of different reasons maybe why our PPID horses in our study didn't seem to show evidence of less responsive protein synthesis pathways than healthier horses, and certainly things that we still need to know more about. So Dr. Pratt-Phillips in her talk talked a lot about insulin dysregulation and what that means. So I'm not going to go into the definition of insulin dysregulation again, but it was also of interest to us in some of these pathways that we study, because as I mentioned earlier, we know that insulin in a healthy horse is one of the things that activates these signaling pathways, which raises an interesting question of what about horses with insulin dysregulation? As Dr. Pratt-Phillips indicated, a lot of our interest is focused more on glucose and carbohydrate metabolism and how does it respond to insulin dysregulation. But where we know protein synthesis is also regulated by insulin, we wanted to know how that might be affected in horses that maybe have prolonged hyperinsulinemia or systemic insulin resistance by their peripheral tissues. So in our first study of horses that I can kind of classify as related to insulin resistance, we did a study that was, again, part of that same study where we had our PPID and our healthy horses, and we wanted to see if those PPID horses had any evidence of being insulin resistant compared to the non-PPID horses as far as the activation of these pathways go. And you can see that regardless of whether they were healthy, so that's the control, so they were still old horses, they were just healthy, or a PPID, both groups, they could activate these pathways in response to fairly high doses of insulin. If I could do this study over again, I would have used a lower dose of insulin. But in some of these things, you learn by doing as you go. So it's possible that if we had just infused a more physiological amount of insulin, maybe we might have been able to tease out differences between the groups. So that's so in follow-up, though, I will say that even though we didn't see a difference between the PPID and the control horses, in these two groups, which collectively were old horses, we did see evidence that they were quite insulin resistant compared to healthy mature horses that we studied at the same time, but in a different study. So what we did for these horses is we infused them with insulin, and then we infused glucose back into them in order to keep their blood glucose levels constant. And then we measured how much glucose do we need to infuse into them to keep their blood glucose levels constant. The higher the rate of glucose infusion means the more sensitive their tissues were to the insulin. And so you can see that both of our old horse groups were pretty insulin resistant compared to a mature healthy horse. So although we didn't necessarily see a difference between our two old groups in their response, they were definitely less insulin sensitive than a healthy younger horse. So then this was some other research that was done with Dr. Lose during her PhD, where she was interested in insulin resistance in horses And so this initial study was, we had horses with equine metabolic syndrome. So not only had hyperinsulinemia, but also their body weight had a higher body condition score, and so on. And we fed them a high protein meal and looked at their responses. And so first thing we saw is the top line here. So with all the A's here, these were our EMS horses. And you can see that even though we fed both groups the same meal and they consumed in about the same time, our EMS group had a much higher insulin response to feeding that high protein meal than our control group. And we also saw that there were quite a lot of differences in plasma amino acid concentrations. And in general, the general trend that we saw for most of the amino acids was that the EMS group here, so the dark bars are our EMS group, they had slightly elevated plasma concentrations compared to our control group. So several of these amino acids were essential amino acids. So when we see higher concentrations in the blood, this can suggest a couple things. It means maybe they have more protein breakdown in the body, so we're liberating more amino acids from breaking down protein, Or on the other side of the coin, maybe they're incorporating their amino acids less efficiently into protein. So this study didn't really give us an indication of what that potential mechanism could be, but did suggest to us that there's something in protein metabolism that is affected by insulin resistance, or EMS. But in this study, we unfortunately did not measure mTOR signaling. So then, as a part of another study, we did actually study insulin dysregulated horses and compared them to non-insulin dysregulated horses. So relatively speaking, healthy horses. And what we found was, for this one protein in particular, it was actually more activated in insulin dysregulated horses than in healthy horses, which was kind of the opposite of what we would have expected. And as she was digging through the literature, she found that the protein that actually activates this protein in human and rodent molecules of dysregulation, or of insulin dysregulation, it's been implicated as actually being part of the disease process of insulin dysregulation. So that might be manifesting here. So again, we don't really know what this means for protein synthesis, but it seems that there's something that's different. And the other bit of data that she saw from this study is, once again, there were some differences in plasma amino acid concentrations. So although we can't yet conclude how muscle protein synthesis and that process in insulin dysregulated horses differs from a healthy horse, we know that there's something going on there, because there does seem to be differences in amino acid metabolism between these groups of horses. So the last section of data that I'm going to show is related to exercise and mTOR signaling. And this is something that certainly is of interest because of athletic horses and muscle, and we know the importance of muscle for athletic performance. But it's something where there hasn't been a ton of research. So I'm going to show some of the stuff that we have and discuss some of those implications. So this is data that was compiled, and it's from more human-based research, but it still probably applies to horses. And this looks at the effect of different things on ultimately whether muscle is going to gain protein or lose protein. And so they summarized a bunch of data related to, compared to muscle that's collected in a fasted resting state, what effect does providing the subject with just protein, or just carbohydrates or insulin, or just exercise, or some combination between those factors have on rates of protein synthesis, rates of protein breakdown, and then the overall protein balance. And so what they found is that like most of these stimuli that I mentioned do increase rates of protein synthesis. But in some cases, they either have no effect on protein breakdown, or they also increase protein breakdown. The one that I'd like to draw your attention to is at the very bottom here. And what this tells us is that when you combine exercise with providing protein and providing carbohydrates, which we know is a trigger for insulin, all at the same time, you have the biggest increase in protein synthesis, and you decrease protein breakdown, which results in a net increase in rates of muscle protein accretion, and is the most stimulatory, or so the most permissive for gaining muscle mass. And this has been confirmed, or at least agrees with, some of the very limited data that we have in horses. So this was a study done by some researchers in Japan, where they exercised 3-year-old horses, and then immediately following exercise, they infused the horses with either just amino acids, just glucose, or a combination of glucose and amino acids. And then they measured the rates of muscle protein synthesis and degradation. And so what they found is that for the groups that received either the mixture, so glucose and amino acids, or just the amino acids, so those are those top 2 lines here, that those conditions seem to result in the greatest rates of post-exercise muscle protein synthesis, and also the lowest rates of muscle protein degradation. So combining the exercise with protein with something meant to stimulate glucose seems to be the best case scenario to really promote a condition where you're going to get a gain in protein mass. This is some data, and it isn't in exercising horses, but I mention it here because leucine is an amino acid that's commonly included in a lot of supplements that are marketed towards exercising horses. And what they found is that if you add leucine to a culture medium that you incubate muscle cells in, it does seem that culturing these cells in leucine activates these signaling pathways. So just like in other species, leucine does seem to be able to activate these pathways that are going to promote muscle synthesis. Now, the level of leucine they fed is it's about double what you'd expect to see in a horse following feeding. But they did a second part of this study where they actually measured the rates of protein synthesis in these cells and found that as you increase the amount of leucine that these cells were exposed to, up to about 200 micromoles, which pretty closely approximates what you'd expect to see post-feeding, you got an increase in protein synthesis. So leucine does seem to trigger or be permissive to activating these pathways. So these protein supplements that are available with leucine, there is some amount of science to support that it could potentially increase rates of muscle protein synthesis. Now, this was a study that was done by one of my master's students who also is an employee at Kentucky Equine Research, and it's part of her master's research. And what she was interested in was different types of amino acid supplementation in combination with exercise and how that might affect these pathways. So she supplemented with an amino acid called N-acetylcysteine. And what N-acetylcysteine is it's actually not really tied into the protein synthesis end of things, but it was being used because it has a big antioxidant function. So they were investigating the role that it might play in muscle recovery following exercise. But from the human and the rodent literature, there is some data to suggest that N-acetylcysteine might suppress mTOR signaling. So that's why she was interested in that. And then we also added those branch chain amino acids, which would include leucine to it. So we had 4 treatments, so no supplement, just the antioxidant, just the branch chain amino acids, or a combination of both. And what she first found was that regardless of supplement didn't seem to affect the activation of these proteins. So the good news is that that antioxidant that they were interested in didn't seem to inhibit mTOR signaling. So that was really good news there. But what she did find was that exercise, just like we suspected, does in fact activate various proteins in these signaling pathways. So it provides evidence that exercise is an activator of mTOR signaling and can encourage muscle protein synthesis. And the time frame seems to be, most sensitive about an hour following the end of exercise, which if we can combine exercise with feeding, where we know that it's most sensitive to feeding in about that 90 minutes, you can start to see maybe how can we combine feeding and exercise together to create a state where we're really encouraging the accretion of muscle. So the last thing that I want to mention, and this is something I hinted at before, is that at this point, we've really only focused on assembling the machinery around. So we can make assumptions and say mTOR signaling increased, so it suggests that muscle protein synthesis might be elevated, but we've never actually directly measured this muscle protein synthesis. So as a next step for something we want to do is we want to actually be able to quantify muscle protein synthesis. So does the activation over here actually translate into more protein being made? And the way that we can do that is using a stable isotope method, where you essentially infuse an amount of a solution that contains a label on one of the amino acids and measure over a period of time how much of that label actually gets incorporated into the protein. So presumably the more incorporation you have in a protein, the faster the rate of muscle protein synthesis is. So if we can get that tool developed and validated, there's all sorts of really cool possibilities we can study. So we can actually look at the effects of maybe different exercise things or different supplementation schemes and actually get a more quantitative number of this increases muscle protein synthesis by this amount. Or in aged horses, we see less protein synthesis in response to feeding. We can make assumptions based on the mTOR signaling, but our next step is really to try and get some numbers behind it so we can get some more concrete recommendations. So bringing us full circle back to where we've started, I hope that what you're going to take away from this is that protein is a really important component of skeletal muscle, and that to moderate or modulate muscle mass, we really are modulating the balance between protein synthesis and degradation. There's lots of different things that can affect these rates, including age, feeding, exercise, and certain disease processes. And that as we learn more about how we can regulate these pathways, as people that manage and feed horses, hopefully we can develop better strategies to manipulate diet, exercise, and combining some of those factors to promote a situation that will either optimize the rate of gain, or in the case of our old horses, help maintain that muscle mass as they get older. And so with that, I would like to thank all of my graduate students over the years that have helped with this, the various organizations and businesses that have funded this research, and all of my collaborators. And I'm going to stop the share, and then I'm happy to take questions.
Awesome talk. Thank you, Dr. Urschel, so much. Yeah, there's been tons of questions coming in. I know we're not going to have time for all of them, but let's start by doing a couple of groups of questions. And I know you alluded a little bit to some supplements, but can you elaborate a little more about what specific amino acid supplements you might recommend, whether it's for horses that just need more top line, or older horses, cushionic horses, anybody with real muscle atrophy?
Yeah. And that's something that we're still trying to get at. I think the key with all of this is protein quality, probably more so than anything. So we do know that the branched chain amino acids from some of that cell culture data seem to be maybe particularly stimulatory to those pathways, but then providing in addition to, I think of proteins and amino acids kind of in two different ways. So one, like the supplement level where you're only providing like a couple grams at a time, you might be activating the pathways, but remember, that's only part of the story. You also need the building blocks that come from the diet itself to build that protein. And so that's maybe where having a well-balanced diet with good levels of crude protein, enough of the essential amino acids come into play. Maybe feeding more or making sure you have enough, especially maybe for your growing horses or your older horses, of that more digestible protein where they're getting more of the essential amino acids absorbed from the small intestine into their bloodstream, rather than a more forage-based. Well, forage is definitely important, but as we're feeding a protein supplement specifically, again, with a 32% like ration balancer protein, it seems like a lot of protein, but you're only feeding a small amount, but it's a pretty highly digestible amount versus feeding lots and lots of a protein that might not be like a 12% protein feed that might not be as digestible. I will always say too, that you get to a certain point where more isn't always better. So I like to use the analogy of, like in humans, we know this inherently with ourselves. We can't sit on the couch and eat steak all day and expect to gain muscle. So it's a combination of diet and exercise that's going to lead to muscle. Just eating more protein isn't the answer. Now, if you're moving from marginal protein to adequate protein, yes, adding more protein or add a higher quality protein will help gain that muscle. But feeding, double the requirement or triple the requirement, it's expensive. It's bad for the environment, because ultimately anything that you feed that your horse cannot use to build protein is going to get excreted out in the urine, or it's not going to get digested. So it's going to get excreted out in the feces. So you're creating really expensive urine and feces, because protein is expensive to put in the diet. And if they can't use it, it goes out into the environment, which has environmental costs, but it's also a waste of your money.
Mm-hmm. Yeah, and right before I ask you your next question, which is actually exactly what you're alluding to, I just want to draw everyone to the chat as well and say that don't forget you will still be eligible for the door prize if you hang out with us for just a few more minutes. And also there is a survey that I'd love you to fill out. But with that being said, you talk about quality protein in the diet, and a bunch of questions came through about what is really the best quality protein in a diet? What is flax meal different than alfalfa meal different than straight alfalfa? Or what about soy? Have they done stuff with whey? Can you comment on just the bigger overall diet and what would be your recommendation for quality protein?
So, really interesting questions. There hasn't been a lot of stuff specifically done with providing exclusively whey protein versus exclusively soy protein. A lot of the research is now older research, so say done back in the late 80s, early 90s by the Texas A&M group, which really was focused more on, say, forage-based protein versus either cereal grain-based protein or, say, soybean meal-based protein. And they did find that for more of the constant, so the protein feeds and the cereal grains, more of that protein tends to be absorbed in the small intestine. So they tend to get more of the protein absorbed as amino acids. With a more forage-based protein source, it's more likely to not get digested until the large intestine, where you're getting maybe less of the essential amino acids absorbed. From other species, so to address more of the question between like soybean meal versus whey. So in humans, for example, whey protein seems to be more stimulatory of these pathways than soy-based proteins. And some of that has to do with maybe the rate at which they're digested and some various factors there. Now, to feed some of it is practicality. So it's cost prohibitive to have like a completely whey-based protein diet for horses. So a lot of the stuff a lot of the really high protein feeds are largely soy-based. I think there's some interesting research opportunities moving forward where we could do some comparisons of, how does whey protein compare to flax protein, compared to maybe some of the more emerging types of protein like hemp meal or some of those other ingredients that are starting to be produced as a byproduct that we just don't know the answer yet. So we know, as I said, I showed that one study where we compared alfalfa-based protein to more of a soy-based protein and found that the soy-based protein seemed to be better at activating those pathways. But that's really the only one where we've directly compared those signaling pathways with equal amounts of protein intake.
Wow, definitely a lot of great opportunities for research, it sounds like. So you're in a good field. So I know we're running a little bit long, but there was a bunch of questions that I'm just going to make you do a little bit of a detour that deal with exercise. So a lot have come through to ask about how much exercise do you really need to see an effect? And if you have a horse that can only do hand walking or any really light exercise, is that enough? Can you just comment kind of along the general lines of exercise?
So again, like a lot of things related to this, there's been very limited study in horses. And in humans, most of it's actually shown that the maximal stimulation of these pathways is actually more resistance exercise. So more like weight lifting type exercise to get a really good stimulation of those pathways. So you could say that in horses, maybe things like show jumping, where they're pushing off their hind end, or like on lighter work, I would hypothesize that maybe, walking up and down hills. And we kind of know that for horses that have a weak hind end, walking them up and down hills seems to help build muscle there. So I think for even a horse that can't maybe exercise that high intent, well, I guess the short answer is we haven't studied it at enough intensities that horses actually do. So in humans, we know that it very much seems to be more resistance-based exercise, and how that actually translates into exercise that's like the horses feasibly do, we don't know. I would hypothesize that even if you have a horse that, you might not be able to do much with and you're trying to encourage it, if you can keep them in a pasture with hills where they have to be walking up and down hills more often to get to water, to get to feed, if they're sound enough to do that. If you're hand walking and can walk them over like cavalettis on the ground, or things where they're needing to, at least for a little while longer, or for even like a little longer instant, bear weight on one leg a little bit more than the other, where you can kind of trigger there. I mean, I think in terms of practical exercises, I've heard people say, well, maybe, you can have horses, pulling carts with different weights and kind of try and trigger weight there. So I think there's some opportunities, but not necessarily that we've studied. I do think probably you're going to see the most effects with more heavy exercise, more resistance type exercise than you would with walking. But I think it would also be of interest to, see, especially maybe in some of these young horse. Well, so Kentucky, we're a big thoroughbred state where we do a lot of sales prepping yearlings to sell at sale. And our yearlings in Kentucky, when they sell them, they are beautifully muscled and they look awesome. And so they are hand walking these horses for tons of time each day. Some of them are swimming their horses. So it would be interesting to see, how can we manipulate feeding in combination with maybe some of these hand walking protocols to encourage that muscle growth, or swimming type exercise. So some of those types of exercise as well. It would be interesting to study those pathways.
Awesome. Well, great answers, great presentation, both. Let's thank everybody, Dr. Urschel, Dr. Pratt-Phillips. I think today has been awesome. I just have a few things in closing, and then we will go ahead and select our winner. I would just like to share my screen just really briefly and share just a few slides with you. And everybody is going to go ahead and get to see my email. The Equine Science Center would really like to thank their partners. These are some partners that have helped make a lot of these programs possible. We have one more webinar in the horse management series, and that is next Wednesday. You're going to hear a lot more on pasture and forage. We've got two great researchers at the University of Maryland talking about alfalfa and talking about obesity and losing weight. So we get to hear more on the obesity topic. If you are in New Jersey, we'd love to have you join us for the free program. It's an Equine Industry Summit. So that is March 16th. So please go on our website and look up and register for that. We've got Giving Day also coming up, or Giving Week actually, March 20th through the 24th. Junior Breeder Symposium on the 25th. Whoop. And then Ag Field Day on April 29th. So we have a whole lot of things coming up. So please visit our website, esc.rutgers.edu. Consider giving back a little bit for helping us with all of our programs. And we hope to see you in the near future. So with that being said, we are recording. I have had tons and tons of questions on recordings. And yes, they are being recorded. We will release all of the recordings the middle of March. So we give it another month. We wait until everything is kind of settled, and then we will release them on our YouTube page. You will all get an email when they will be released, and you can share that, and they're open access to everybody. So we will be recording those. Please fill out that survey that Kyle posted. I'll ask him to post it one more time in case it got lost in the chat. These webinars are based on the feedback I get from previous years. The reason why we're doing so much nutrition this time around is because last year, all of the comments were, we want more nutrition. So that's why I've done 3 full webinar days of nutrition. So I'd really like your feedback on how these are. If you already filled it out for the last one last week, fill it out again, because they're very webinar specific. I want to hear what you thought of these particular speakers. You don't have to fill in what you thought and what you want to hear again, but I'd love to have your information as to how you like the webinars. So with that being said, let's see if Eileen Cleese is still on our roster. And if you are, please go ahead and type in the chat that you are on and you are our winner. So Eileen Cleese, K-L-E-E-S, and we'll wait a minute and see if she goes ahead and logs in the chat. Otherwise, I have another name, so you might be the next person if I don't hear from Eileen Cleese. And I'm trying to just scroll through our huge list of attendees to see if she might still be there. And I actually don't see her. So, oh, she raised her hand. Okay, then that's why you are up there. Then you're up at the top and not in the E's. So just go ahead if you would, type in the chat that you are there, and then we're going to send your email off to to Kelly Payne at Triple Crown, and you will get awarded your prize, and you'll get to select your prize. So thank you again, everyone, for attending. We really, really appreciate your attendance. We hope to see you again next week, and look forward to hearing more from you. So take care and have a good rest of your week, and we will see you next time.